In this video, we are going to be graphing parabolas with the axis of symmetry, focus, and directrix. So let's get started. First, we're going to be graphing all of these parabolas in vertex form. The vertex form of a parabola is y equals ax minus h squared plus k. So the vertex is represented by hk. So that means our vertex is at 3 and 8. 3, 8. And a is negative 2. And since our vertex, our a is negative, it opens down. Our axis of symmetry, since this is based on, since it's y equals a value of x, the axis of symmetry is going to be based off of x, and the vertex and the x value in the vertex is 3, so that means our axis of symmetry is equal to 3. So let's graph all of these points first. Okay, we graphed that. Now we need to graph the axis of symmetry. Okay, now that we have the axis of symmetry and vertex down, we can now start to plot points. Oh, and the vertex is the turning point or corner of the U-curve that makes the sharpest bend. And the axis of symmetry is an imaginary straight line that cuts the U shape into two identical mirrored halves. So the rule I generally go for is 1A, 3A, and 5A. So this is how it's going to work. Since A is equal to negative 2, we have to multiply everything by negative 2. So negative 2, negative 6, and negative 10. So how does this work? Basically, you go out one point, and then you count negative 2. So that means our next point is right here. And then 1 out, and then 6 down. So that's 4, that's 5, and that's 6. Okay, so then our point should be right there. And this is mirrored over to the other side. And now for negative 10. Move down 1 unit here, and then another unit down like there. So let's graph that. And now we can graph. And now we have to find the focus and the directrix. To find the focus, all you have to do is do 1 over 4a. This is -2, and this equals -1/8. So that is the distance from the focus to the center. The focus is generally inside. Oh, and if you don't understand what the focus is, I'll just graph one right here. So this is a parabola, and the focus, since this has an a value of 1, the focus will be, so 1 over 2 times 1, so equals 1/2. So the distance will be right here. So the focus is always going to be the inside of the parabola. And now for the directrix, that is here. This is the directrix. So what this basically says is, hang on, I need to make this more half. What this basically says is the distance from the vertex to the distance from the vertex to the foci and the foci to the directrix will always be the same. So, for example, if we go here and then straight down, that will be the same distance. And that's basically what a foci says, or it is. And a foci is also used to a foci is also used to determine like how curvy like the parabola is. Yeah, so the distance from the vertex to the focus is equal to the distance from the vertex to the directrix. Okay, so now that we understand what it is, we can start plotting. So this means the focus of this equation is 3, 7, 7 over 8, and the directrix is 1/8 added, so it's 8, 1 over 8. So it's right there. So that's the foci, and this is the directrix. And the domain is simple, so the domain is -infinity to infinity, and the range is going to be -infinity to the vertex, so that's 8 and bracket, because the value of 8 is included. Okay, so now that we have that clear, we can start graphing the second question. So this starts with x. So for a horizontal hyperbola, the vertex form of it is hang on. Yeah. So since this starts with x, our vertex form is still a, but this time it's different. It's y minus k squared plus h. So still h of k. So it's going to be 2 comma 1. And a is negative 3. And since it's negative, it opens to the left. So let's plot these points. An axis of symmetry, since this is a horizontal hyperbola, we're going to be basing this off of the y of the vertex. So this is just going to be y equals 1. Okay, and now for the 1A, 3A, 5A rule. So here, another point here. That should be in white. And another point here. And another point here. Now for the focus, so 1 over 4 times negative 3, that's 1 over 12. This is obviously going to be very, very close to the vertex, so I'm not even going to even bother trying to actually measure it out. And that's the vertex. Not vertex, that's the directrix, and that's the foci. The focus is written as 1 over 11 over 12, and that's 1. And the directrix is x equals 2 and 1/12. And the domain is just negative infinity, 2, and then the point is at 2 comma 1, so it's just there at 2, and the range is negative infinity to positive infinity. Okay, 2 more questions to go. So the vertex of this is at 3, negative 3. A is 1/3. And it opens to the right since it is positive. So let's graph this. And the axis of symmetry is y equals negative 3, because of this number. Okay, and now for 1a, 3a, 5a. So this is going to be 1/3, 1, and what is 5 over 3 equal? 1.66 repeating. Right around here. So that's not exactly matching up. I don't think it would. Yeah, wait, these points are wrong. It could be 1.66 repeating. Hang on 1 second. Oh, wait. Yeah. So since we can't really plot this using 1a, 3a, 5a, I guess we have to plug in negative 10. I mean positive 10. Right, so if we put in, so we set x, why isn't this zooming in? X equal to 10. So we're trying to find the y value. So y would equal approximately 1.58. Hang on. Yeah. So around right here. So 3, 4, 4. So right around there. Yeah, and that's our parabola. That's still not really 1.5. And notability parabolas will never be perfect. I guess it's just like that. Here, since, yeah, I guess we can just keep it like that. And focus 1 over 4 times 1 over 3. So that's 3/4. So 3/4, comma, -3. And the directrix is x equals 3 minus 3/4. So what's that, 2 1/4? And time for the domain. The domain is going to be 3, comma, infinity, -infinity, comma, to infinity. And time for the last one. So let's speed run this. So HK, -3, -4. A is 1/2. Opens upward since it's positive. Axis of symmetry is based on the x values, so x equals -3. Now let's start graphing. I do want this parabola to look good because this is going to be in my thumbnail. Okay, and the axis of symmetry. Now it's time to graph. Hang on, 1/2. Where is this? Is this equal on both sides? Just checking to be sure. Okay, so basically what I want is I want to find where this, because I want this graph to be accurate. So 1/2. This step isn't really necessary, but I'm still doing it. Right, and then what's the value of x? So x equals negative 8.29. So where is that? Here. Okay, but now, yeah, notability graphs aren't really the best for parabolas, because now if you look here, that's not really 1/2. Yeah, and I graphed everything right too. If you guys know what's wrong with the app, let me know. Hang on, let me plug in. Wait, let's try to find the other value of. I mean, it should be just the same, but on the opposite side, right? Yeah, it should just be 2.29. But then both sides aren't equal. Oh, because this is over here. Oh, okay. Oh, and then this is right here. Yeah, now it goes through correctly. Okay, well, we fixed our graph. Dude, what is going on? Okay, time for the foci and directrix. Since it's 1 over 4 times 1/2, that equals 1/2. And then 1/2 through here. And the points are -3, -3.5, and y equals -4.5. And the domain is -infinity to +infinity, and the range is -4 to infinity. Okay, so yeah, that's how you do that. And unless you guys, yeah, so these are word problems, but parabolas have other functions too. So like this could be like a rocket ship. So let's say this is a rocket ship, right? So the rocket ship would move down like this. It's kind of hard to animate at the same time. But it'd go up like this. Yeah, like that, and then it'd fall down. So that's one application, and then a radio telescope. Basically, the foci is here, so everything would bounce off evenly. Coming in, coming out. Also, if it bounced off like this. Yeah, so that's how you use the foci. Yeah, that's some technical application. So yeah, thank you for watching.